The terrifying reason your own thirst hollows out the ground beneath your feet, and in California's Coachella Valley, it dropped 11 inches in 36 months while you slept. There is a desert swallowing itself. Right now, scientists have the satellites, they have the data, they cannot stop it. What's pulling the ground down is something you used this morning. Every time you turn on a faucet somewhere in the American Southwest, a pump runs. Deep underground, 50, 100, 200 feet down, ancient water gets pulled toward the surface. Water that took 10,000 years to collect, gone in decades. But here's what they didn't tell you. When that water disappears, the ground doesn't stay hollow. It collapses inward, slowly, permanently. The sediment that was held apart by water pressure crushes together like a wet sponge going dry. And once it compacts, it can never expand again. That aquifer is gone forever. And the land above it, it drops. This is called subsidence, and it is accelerating. In California's San Joaquin Valley, not a distant wasteland, but the place that grows a third of America's vegetables, the ground has sunk 28 feet since the 1920s. 28 feet. A 3-story building swallowed by the earth. NASA's satellites are watching it happen in real time, and the numbers keep getting worse. Between 2015 and 2017 alone, parts of the Coachella Valley dropped nearly 11 inches. That is almost an inch a month. Roads buckled, irrigation canals warped, water mains cracked and started leaking, the very resource that caused the collapse in the first place. But California isn't the only place. This is happening on every inhabited continent simultaneously. Iran's Mashhad Plain is dropping 25 centimeters every year. Mexico City, built on an ancient lakebed, is sinking at 30 centimeters annually. The ground beneath 45 million people is falling. The reason nobody panics: you can't see it happening. Here is where it gets strange. You would expect geologists to have a solution, a fix: pump the water back in, rebuild the aquifer, reverse the damage. They can't. This is what makes subsidence different from almost every other environmental crisis on Earth. You can replant a forest. You can clean a river. You can pull plastic from the ocean. You cannot uncrush sediment. Once those ancient clay and sand layers have compacted under their own weight, that storage capacity is gone, permanently. The same aquifer that held water for 10 millennia will never hold that water again. Scientists have known this since the 1970s. They published the research. They rang the alarm. The pumping accelerated anyway. Now here is what the maps show that nobody is talking about. The sinking isn't uniform. It happens in patches, in columns, in sudden drops that don't follow the surface at all. A road can be perfectly stable on one side and 8 inches lower on the other. This is called differential subsidence. And that unevenness is what makes it lethal to infrastructure. In 2023, railroad tracks running through California's Central Valley developed a visible kink. The rails had shifted, not from an earthquake, from the ground collapsing beneath them at different rates on each side. Bridges designed with zero tolerance for ground movement are now sitting on earth that has moved. Gas lines running through the subsidence zone flex and microcrack. You don't hear the crack, you smell nothing. But the leak is already there. The Dead Sea Basin is sinking for the same reason: water extraction draining the aquifer system below. And in the 1980s, sinkholes started opening, randomly, without warning, dozens of feet across, dozens of feet deep. A beach that was solid sand in the morning was a 30-foot crater by afternoon. The Coachella Valley sits directly above an aquifer system that JPL, NASA's own jet propulsion laboratory, has flagged as a critical subsidence zone. The buildings there were engineered for ground that no longer exists at the depth it was built for. The soil those foundations are gripping is not the same soil they were poured on. So what does this actually mean for you? It means there are structures standing on a premise that is no longer true. The soil surveys, the engineering calculations, the safety margins, all of them calculated for ground that has since contracted. That gap between the original assumption and today's reality is exactly where the risk lives. It means California's ambitious aquifer refill programs are fighting that war with a smaller bucket every year. As the ground sinks, the aquifer holds less. The math gets worse, not better, with every season. And it means the deserts aren't stable. They are dynamic, moving downward. Every city built in them, every farm irrigated by them, every highway crossing them is sitting on something that is quietly, invisibly, constantly becoming less than it was. You live above aquifers too. The question scientists cannot answer isn't whether it will stop. It won't. The question is where the next differential crack appears, which bridge, which gas main, which neighborhood wakes up to a road that used to be level. There are places in Arizona, Nevada, and Texas where the subsidence mapping hasn't been fully published yet. Not because the data doesn't exist, because some of it was collected under contracts that restrict public release. Someone knows exactly where the next piece of ground is going to drop, and they're not telling you.